Everyone, I'm putting this video together to walk through the solutions of project 2. Now please keep in mind that you're supposed to work through all the questions yourselves first and then check your answers against this solution. This project is meant to prepare you for test 2. The questions in test 2 are going to be very similar to the questions on the project, so it is in your interest to work through these and make sure you master how to work and how to solve these questions. All right. So to begin with, we will go through the multiple choice section first. It says list all possible rational zeros. So in order to find the possible rational zeros, we have to apply the possible rational zeros theorem, which is the P over Q method. All right. So we have a function given here, minus 4x to the fourth plus 2x squared minus 3x plus 6. All right. So we have to first identify, again, we are using the P over Q method. All right. We first have to identify which of these is the P and which one is the Q. So the P is always the last coefficient in an ordered polynomial. So the last term, which is usually the constant term, is going to be P. All right. And the coefficient of the first term is going to be Q. So in this case, Q is -4 and P is 6. Now in the next step, what we must do is factor P and Q. Find factors of P and Q. So I'm going to write P equals 6 and express that in factors. So plus minus 1, plus minus 2, plus minus 3, and plus minus 6 are all the factors of 6. Now we take the value of Q, which is -4, and find factors of that. So plus minus 1, plus minus 2, plus minus 4. These are the factors of Q, -4. Now we have to form ratio of P over Q using all these values. So that means 1 plus minus 1 over plus minus 1, plus minus 2 over plus minus 2, plus minus 3 over plus minus 1, and so on. All right. And then you have to form ratios with plus minus 1 over plus minus 2, plus minus 1 over plus minus 4. So all possible ratios, combination of P's and Q's, must be put into ratios. All right. So let's do that. We'll first use the plus minus 1 of Q and run the list. So these numbers, the factors of P over plus minus 1, will be these numbers, right? Plus minus 1, plus minus 2, plus minus 3, and plus minus 6, right? That's when we take all the factors of P and divide by plus minus 1, the first factor of Q. The next set will be using plus minus 2 in the denominator. All right. So that would be plus minus 1/2, plus minus 1/2, plus minus 1, right? 2 plus minus 2 divided by plus minus 2 is 1. Then plus minus 3 over 2, and then plus minus 6 over 2, right? And then finally, we have to have the denominator as plus minus 4 and come up with the ratios. So that would be plus minus 1/4. Okay, plus minus 1 divided by plus minus 4 would be plus minus 1/4. Then there's plus minus 1/2, which is 2 over 4. So plus minus 1/2, then plus minus 3/4 and plus minus 6/4, which is going to be 3/2, correct? 6/4 is same as 3/2. And so we will see that there are some common values, all right? So we will eliminate this because this, we already have a plus minus 1. And then we have, do we have a plus minus 2? No. Plus minus 3. This one, 6 divided by 2 is a plus minus 3. So I'm going to remove this one. Then plus minus 1/4 appears only once. Plus minus 1/2 appears once. Plus minus 3/4 appears once. And plus minus 3/2 appears twice. So let's get rid of one of them, because we don't need to duplicate the possible rational zeros. So now let's shortlist, all right? Now I see here in B and D there is a plus minus 4. We don't have a plus minus 4 anywhere, so these two are automatically eliminated. Our choice would be between A and C, all right? So there is a plus minus 1/4, plus minus 1/2. Do we have a plus minus 2/3? No, right? We don't have a plus minus 2/3 in the answer that we worked out here on the side. So A is not the choice. C. Let's see if all the rational zeros listed here match with our answer here. This plus minus 1/4, plus minus 1/2, plus minus 3/4, plus minus 3/2, and then plus minus 1, plus minus 2, plus minus 3, and plus minus 6. All right. So that solves question 1 of the multiple choice. Now question number 2 says divide x to the 5th plus x cubed minus 2 divided by x plus 3. All right. Now, since this just says divide and doesn't tell us what particular method we should be using, you can work it out any way you want. Long division method or the synthetic division method. You know that the synthetic division method is much faster. So I'm going to work this out using the synthetic division method. All right. Now, in order to use the synthetic division method, we just need to work with the coefficients. All right. But any missing coefficients must also be written out as 0. We see over here in x to the 5th plus x cubed minus 2, there are some terms not visible. X to the 4th is not visible here. X squared is not visible. X is not visible. But we have to bring them out by writing those coefficients as 0. Okay? So, in other words, all right, x to the 5th plus x cubed minus 2 should be written as, to bring out the missing terms, we should write it as x to the 5th plus 0, x to the 4th plus x cubed plus 0, x squared plus 0x minus 2. All right, that's going to be the numerator, all right, of this division. And then for the denominator, remember the denominator has to first be expressed in x minus c form, all right, and what we divide by in synthetic division is going to be the value of c after pulling out the negative sign. So here we have x plus 3. So if we put it in x minus c form, it's going to be x minus 3, right? Minus 3. So our c, with which we are going to perform the synthetic division, is going to have a value of negative 3. So now let's set up our synthetic division problem. Just use the coefficients. All right, the first one here, the coefficient is a 1. So I'm going to write here 1. And then the next one is 0. for x to the fourth, then the coefficient of x cubed is a 1. Then we have a 0, another 0 for 0x, and the last one is minus 2. All right, and then we put the sign separator for our synthetic division, and then on the other side of it we write minus 3. That's the value of c. So keep in mind, if you have your denominator in x plus 3 form or x plus any value form, you have to first rewrite it in x minus c and extract the exact value of c. Okay, so now we can start the synthetic division. I'm going to draw a line here. So for the first one, all right, for the first number 1, I write that below the line. And then we do a multiplication. Minus 3 times 1 is minus 3. So I write that below the second coefficient, which is 0. So 0 plus minus 3 is minus 3. Then we have to do the multiplication again. Minus 3 times minus 3 is positive 9. So I'm going to write a 9 below the 1, which is the third coefficient, and do the addition. 9 plus 1 is 10. Now 10 minus 3, again multiply these two values, 10 and the c minus 3. Sorry about that, just a second. Okay, 10 times minus 3 is minus 30. Okay, so we get 0 plus minus 30 is minus 30. Minus 30 times minus 3 is positive 90, right? So we write a 90. 90 times negative 3 is negative 270. And when we do the last addition, it's minus 272, right? Minus 2 minus 270 is minus 272, and this is our remainder. This is the remainder, and we have to form the quotient using all the other values under the line. The last one is set to be the remainder. Now, to put the variables, what do? We have a highest exponent in the original polynomial. The highest exponent was 5. So the quotient, the exponent is going to have 1 less than the leading term in the original polynomial. So it's going to be 1x to, let me write it separately here, 1x to the fourth, all right, minus 3x squared, x cubed plus 10x squared minus 30x plus 90 plus the remainder minus 272. So I'm going to remove that and write it as minus 272 over, what was the denominator, x plus 3. So let's see which of these choices agree with the answer we found here. X to the fourth minus 3x cubed, I'm looking at A first, plus 10x squared minus 30x plus 90 minus 272 divided by x plus 3. So this matches with our answer here. So I'm going to circle A, but I'm also going to check out the rest of the answers. All right, so this doesn't have the x cube, all right, x cube, the x and all that, and it doesn't have the correct remainder either. Neither does this one. I don't know how they got a 9 here. All right, so this C is definitely not the right answer. D is definitely not the right answer either. So A is the correct answer. Now question number 3 says use synthetic division and the remainder theorem to find the indicated function value. They've given us a function x to the fourth minus 4x cubed plus 2x squared plus 9x plus 7, and they want us to find f of 2. However, they want us to use the synthetic division and the remainder theorem. Now, what does the remainder theorem say? It says that after performing a synthetic division, the remainder is what you will get if you had evaluated the function with whatever you performed the division with. That means the c value in the x minus c form of the divisor. So let's try that out here. I'm going to perform a synthetic division on this polynomial and divide it by 2. All right. So what are the coefficients here? Let's first put it in synthetic division format. I'm going to put a 2, and where do I get the 2 from here? All right, this is the 2, and then on the other side I'm going to put all my coefficients of the polynomial. So for x to the fourth it's 1, then negative 4 for the second term. Coefficient of the third term is positive 2, and then we have 9, and finally 7. All right, so 1, 2, 3, 4, 5, and it's an ordered polynomial arranged from the highest exponent to the lowest exponent, and all the terms are visible, right? We have all our terms. And so now we can go ahead and perform the synthetic division. Bring down the 1 first, all right, then multiply 2 times 1 is 2. I write the result under the second coefficient, which is minus 4, and add them. Minus 4 plus 2 is minus 2. Multiply minus 2 by 2, and we get minus 4. Minus 2 times 2 is negative 4. Negative 4 plus 2 is again negative 2. Negative 2 times 2 is again negative 4. 9 minus 4 is 5. 5 times 2 is 10. And 7 plus 10 is 17. All right. So this, the last value from the synthetic division, is our remainder, correct? That's our remainder. So based on the remainder theorem, the f of 2, all right, if we took this 2, which we performed the synthetic division with, and plug it into f of x in the function wherever there is x, if we replace all the x values with 2 and evaluate the function, we are going to get a value equal to whatever the remainder is from the division. All right, so it's positive 17. Our answer is going to be positive 17. So f of 2 is going to be equal to 17, and we came up with the answer by not by plugging in 2 into the function, but by performing the synthetic division using 2 as our c, and then finding the remainder. All right. Number 4 says find the domain of the rational function f of x. The rational function is x plus 9 divided by x squared minus 64. Okay, so they want us to find the domain. That means all the x values that can be input into the function, correct? Now, because this is a rational function and there is a denominator, we have to exclude values of x that will make the denominator equal to 0. So I'm going to make x squared minus 64. In order to find what values of x will make x squared minus 64 equal to 0, I'm going to take x squared minus 64, make it equal to 0, and solve for x. Now I'm going to use the difference of squares to factor this first, and then I'll find the values of x. You can also use the square root method. Both should give you the same results for x, all right? So x squared minus 64, x is a perfect square, 64 is a perfect square, and it is a difference minus, so I can write it as x minus 8 times x plus 8 equal to 0. I'm going to make each factor equal to 0 and solve for x. So x minus 8 equal to 0, therefore x is positive 8, and x minus 8, plus 8, the second one, equal to 0, therefore x is negative 8. So these are the two values of x that must be excluded from the domain of this rational function. So which are the right choices? Now you see over here they have given it to us in set notation, not in interval notation. So what are the choices given to us? Make sure you read the set notation correctly. The first one says x such that x is not equal to negative 8 and x is not equal to positive 8. Right? I think A is the right answer because that's what matches with the solutions of x that we found. But let's look at the other choices here. B says x such that x not equal to 0 and x not equal to 64. No, this is not an appropriate choice. This one says x such that x is not equal to negative 8 and positive 8, and I don't know where they came up with the negative 9, so this is not the right choice. And yes, definitely all real numbers is not the right solution. So A is the right choice for number 4. Question number 5 says, use the graph below to answer the following question. So we have here a graph of a rational function, and the question is, as x approaches 3 from the positive side, f of x approaches what value? All right. Now, this is a question on vertical asymptotes. All right, and interpreting the arrow notation of rational functions. So we have to check the behavior of the graph. We see there is a vertical asymptote. Well, they haven't drawn the vertical asymptote yet here, but we can figure out that this graph, all right, this particular graph coming from the positive side of x is rising at x, or rising along x equals 3, right? This value here is 3 on the x-axis. So this is the vertical asymptote that I just drew with a dashed line, and the graph of the rational function, whatever it may be, is rising to infinity along that asymptote. So what does this say here? As x approaches 3 from the positive side, so positive side is going from the right to the left along the x-axis, we see that it's rising unbounded without restrictions. So f of x equals positive infinity, right? So where is positive infinity? D is the right choice. Now, if the question were to say as x approaches 3 from the negative side, just a second, as x approaches 3 from the negative side, then f of x would be equal to what, or would approach what? So this is the graph at the bottom, is the one that is approaching x, this vertical asymptote from the left hand side, right, from here all the way. And we see that it's falling, the function is decreasing, the graph is falling, unbounded along the same vertical axis x equals 3. However, it's approaching the vertical asymptote from the left hand side. All right, so, and where is it headed towards? Negative infinity. It's headed toward negative infinity. This one up here was positive infinity. So then the answer would have been negative infinity. But for the question they asked, the choice should be D. All right, D should be our choice. Let's go through the last question in our multiple choice section. It says, find the vertical asymptote, if any, of h of x equals x plus 2 divided by x times x plus 2. So to find the vertical asymptote, we need to take the denominator. It's very similar to the way we find the domain of a rational function, right? So the denominator here is x times x plus 2. Make the denominator expression equal to 0 and solve for x, right? So we have two factors here. One is just x, the other is x plus 2. So we use the zero factor property to solve for x. First make x equal to 0 and then take the next factor, which is x plus 2, equal to 0. So x equals negative 2. So the two vertical asymptotes will be at x equal to 0 and x equal to negative 2. Now x equal to 0 is the y-axis essentially, all right? And x equals negative 2. So there are two vertical asymptotes. So B is the right choice. The first one, A, is x minus 2 and x minus 2. Now, they both are the same. So this is not valid. X equals negative 2. Now, no vertical asymptote is also not correct. B is the right choice. X equal to 0 and x equals negative